Hello everyone, welcome back to the Atharva Gate Academy. Myself Chinmay Daduk. In previous video, we have completed the solutions of chapter 2 of Strength of Materials. Now in this video, we are going to start solving questions from chapter 3, Bending and Torsion. First question is from year 2003. The beams, one having square cross section and another circular cross section, are subjected to the same amount of bending moment. If the cross sectional area as well as the material of both the beams are same, then option A, maximum bending stress developed in both the beams is same. The circular beam experience more bending stress than the square one. The square beam experience more bending stress than the circular one. And option D, as the material is same, both the beams will experience same deformation. Let's say here bending stress is sigma. So in first option, we can say that bending stress in square cross section is equal to bending stress in circular cross section. Here in second option, we can say that sigma C is greater than sigma S. In third option, we can say that sigma S is greater than sigma C. And in fourth option, deformation is same. So actually here we have to compare the bending stress in both these beams. Fine. Now let's say square cross section of beam is having side A and circular cross section of beam is having diameter small d. Now in the question it is given that cross sectional area is same for both these beams. So we can say that A square is equal to pi by 4 d square. Right? This A square is area of this beam and this pi by 4 d square is area of this beam. Fine. Now we know the bending equation, that is sigma divided by y is equal to m divided by I is equal to E divided by R. Right? Here if we will compare these two terms, then we can find out sigma, that is my by I. Right? And here the stress is bending stress in this beam. Now here bending moment is same for both these beams. So here m is same for both the beams. Now here we have to find out y and I for both these beams. Fine. Now we know that here neutral axis will be this, and for this beam this axis will be neutral axis. We know that this y is the distance from neutral axis where we want to find out bending stress. Now here we have to compare the maximum value of bending stress. So we have to take maximum value of y. So in this case, if we take maximum value of y, then it will be this distance. And here y will be diameter by 2, right? And for this case, this distance will be the value of y for this beam. So here y will be a by 2. Fine. Value of I for circular cross section area is pi by 64 d raised to 4. And value of I for square cross section beam is 1 upon 12 into a raised to 4. Right? That we have discussed in the theory part. And let's say if we have one rectangular cross section like this, and if we want to find out I about this axis, then it is 1 upon 12. Let's say here this height is h and this width is b. So it will be h cube into b. This is the equation to find out value of I for rectangular cross section. And here both the side is a, so it will be a cube into a. So finally I is 1 upon 12 a raised to 4. Fine. Now from here we are going to compare value of sigma for both these beams. Let's say here we take sigma c divided by sigma s. So it will be my by I for circular cross section beam and divided by my by I for square cross section beam. Here value of bending moment is same for both the beams. So it is cancelled. And now we will put value of y and I for both these beams. For circular cross section it is d by 2 divided by pi by 64 d raised to 4 divided by a by 2 divided by 1 upon 12 a raised to 4. Fine. If you will simplify this, then you will get 16 divided by 3 pi into bracket a by d raised to 3. And from this expression we can find out ratio of a divided by d. From this expression we can find out a divided by d. It will be root pi by 4, right? And now we have to put this value here. So if you will put this root pi by 4 instead of a by d, and if you will calculate this value, then it will be greater than 1. Means we can say that sigma c divided by sigma s is greater than 1. So we can say that sigma c is greater than sigma s. Fine. And from here we can say that value of maximum bending moment in the beam having circular cross section will be more than the value of maximum bending stress in the beam having square cross section. So here our answer will be option B. The circular beam experience more bending stress than the square one. Fine. And this question is for 1 mark. Next question is from year 2003. Maximum shear stress developed on the surface of a solid circular shaft under pure torsion is 240 megapascal. Value of tau maximum is 240 megapascal. If the shaft diameter is doubled, then the maximum shear stress developed corresponding to the same torque will be dash. Let's say initial diameter is d, then final diameter will be 2d, right? Because shaft diameter is doubled. Now we know the torsion equation, that is tau by r is equal to T by J is equal to G theta by L. Fine. If we compare these first two terms, then we can say that tau is equal to T into R divided by J. Here this R is maximum value of radius of shaft and this tau is maximum shear stress. Fine. Here this T is value of torque on the shaft and J is polar moment of inertia. We know that value of J for circular cross section area is pi by 32 d raised to 4. And here we can say that this R is diameter by 2, right? So from here tau is equal to 16 t by pi d cube. Here you can remember this equation, because many times we are going to use this equation to solve questions. Fine. Now here it is given that torque is same. So value of T will be same for both the cases. Now let's say here we take tau initial divided by tau final. So that will be 16t divided by pi d initial cube divided by 16t divided by pi d final cube. Right? Now here value of T is same, right? So finally Ti divided by Tf is d final cube divided by d initial cube. And here we have value of initial maximum shear stress, that is 240 megapascal, right? So we can say that 240 divided by tau final is equal to d final, that is 2d, divided by initial diameter is d raised to 3, right? So from here if you will find tau final, then you will get value 30 megapascal. So here our answer will be option C. This question is for 1 mark. Next question is from year 2004. A torque of 10 Newton into meter is transmitted through a stepped shaft as shown in the figure. The torsional stiffness of individual section of length MN, NO and OP are 20, 30 and 60, having unit Newton meter per radian respectively. Fine. Here we have to find the angular deflection between ends M and P of this shaft. Means we have to find angular displacement between this point and this point. Now see, we know the equation that F is equal to K into X. Here F is force, K is stiffness and X is deformation. But this equation is for linear deformation of this shaft, right? Means it is for axial loading condition. And we also know that this equation is for spring. Understand that if we apply axial loading condition on this shaft like this, then we can use this equation. But here we are applying torsional loading condition, right? So we have to use another equation, that is T is equal to Kt into theta. Here this torque is equivalent to force, this Kt, which is torsional stiffness, is equivalent to stiffness, and here this theta, which is angular deflection, is equivalent to x, that is linear deflection. Fine. So here we will use this equation to find out value of angular deflection. Fine. In this shaft we want to find out angular deflection between m and p, theta mp, and we know that theta mp is equal to theta mn plus theta no plus theta op, right? And from this equation we can find out theta, that is T divided by Kt, right? So it is T divided by Kt for Mn plus T divided by Kt for No plus T divided by Kt for Op. Now here value of T will be same for all these three parts, because we know that if we want to find out torque in any part, then we take one section in that part and we take either left hand side of the torque or right hand side of the torque to this section. And here if we will take left side of the torque to this section, then it will be this T for all these three parts, right? So here we can take common T into, it will be 1 upon Kt for Mn plus 1 upon Kt for No plus 1 upon Kt for Op, and value of torsional stiffness is given to us, that is 20, 30 and 60. So it is 1 upon 20 plus 1 upon 30 plus 1 upon 60. And here value of T is also given, that is 10 Newton into meter. So here we can put 10. Fine. Here unit of this torque is Newton into meter and unit of this stiffness is Newton into meter per radian. So final value will be in radian, and if you will calculate this value, then you will get 1 radian. Fine. So here our answer will be 1 radian, and here this option B is 1 radian. So answer is option B, and this question is for 1 mark. Next question is from year 2004. A solid circular shaft of 60 mm diameter transmits a torque of 1600 Newton into meter. Here diameter is given 60 mm and value of torque is 1600 Newton into meter. We have to find out the value of maximum shear stress developed in this shaft. Fine. Tau maximum is equal to question mark. We have discussed the equation that tau is equal to 16T by pi d cube, right? Here this tau is maximum value of shear stress, this T is value of torque, and D is the diameter. Now see here, if you will take this torque in Newton into mm and if you will take this diameter in mm, then finally you will get this shear stress in Newton per mm square, means it will be in megapascal, right? Because 1 Newton per mm square is 1 megapascal. So here we have to take this torque in Newton into mm, and if you will convert this torque in Newton into mm, then it will be 1600 into 10 raised to 3 Newton into mm, right? Now we have to put this value here. So it is 16 into 1600 into 10 raised to 3 divided by pi into bracket 60 cube. And if you will calculate this value, then you will get 37.72 megapascal. And that is the answer. And this simple question is for 2 marks. Fine. Next question is from year 2005. The two shafts AB and BC of equal length and diameters D and 2D are made of the same material. They are joined at B through a shaft coupling that is shown in this figure, while the ends A and C are built-in cantilevered, means these both ends are fixed. A twisting moment T is applied to the coupling, means here we apply twisting moment like this. If TA and TC represent the twisting moments at the ends A and C respectively, then here we have to find out relationship between TA and TC. Fine. Here actually this TA and TC are the reactions at these ends, right? Let's say here this twisting moment T is applied in clockwise direction when we view from this side. And if we apply this twisting moment in clockwise direction, then reactions will be in anti-clockwise direction at these ends, right? Here reaction is TA and here reaction is TC. Fine. We have discussed this type of question in theory part, but here little bit variation is there. Now we know that total deformation between A and C is 0, right? Because both the ends are fixed, and we know that theta AC is equal to theta AB plus theta BC, right? Because both the shafts are in series connection. We know the torsion equation tau by R is equal to T by J is equal to G theta by L. Fine. And here by comparing these two terms we can find out value of theta. The equation of theta is TL by GJ, right? Now here in this case length is given to us and we can find out J, because we know the equation of J. Equation of J, that is polar moment of inertia, is pi by 32 d raised to 4, right? Now we will put this expression of theta here. So it is TL by GJ for AB plus TL by GJ for BC, and it is equal to 0. Now see, value of L and G is same for both these bars, so we can take common L divided by G. Now here we have to find out T and J for both these shafts. We can find out J from this equation, and we know that how to find T for both these shafts. To find out T in AB part, we will take one section in AB part like this, and here we will take summation of this twisting moment applied on this shaft left side of this section, and on the left side there is only one twisting moment, that is TA. So we can say that T for AB is TA. So here in the bracket it is TA divided by J for this shaft will be pi by 32 into d raised to 4. Pi by 32 d raised to 4 plus what will be the value of T for this shaft. To find out T for this shaft, we will take one section in this shaft and we will take summation of all the moments left side of this section, and on the left side there are two twisting moments. Here this twisting moment is TA and this twisting moment is T. It is acting in anti-clockwise direction and it is acting in clockwise direction. Now here we have taken anti-clockwise direction as positive, so this twisting moment will be negative. So T in BC will be TA minus T. And here if we take right side of the twisting moment, then it is TC, right? Now remember that for twisting moment applied on this shaft, if we take anti-clockwise twisting moment as positive on the left side, then anti-clockwise twisting moment on the right side will be negative. That you have to remember. So here we have to take this TC as negative. And if we put this TC here, then it is TC divided by pi by 32 into this diameter for this second shaft is 2D. right? So here we have to put 2d. So it is 2d raised to 4 is equal to 0. And here this tc is minus, right? Now from this expression we can find out relationship between TA and TC. And if you will simplify this, then you will get answer as option C, TC is equal to 16TA. Now see, if you take this twisting moment TC as positive, then finally here you will get TC is equal to minus 16TA. Fine, that is only going to be the change if you take this sign positive. But I hope that you understand this. And here this question is for 2 marks. Next question is from year 2006. For a circular shaft of diameter d subjected to torque T, the maximum value of the shear stress is dash. Here we have to find out the maximum value of shear stress in this shaft which is subjected to torque T. Now we have discussed the equation to find out maximum value of shear stress in circular shaft, right? We have directly remembered the equation to find out maximum shear stress, that is 16T by pi d cube, right? So here our answer is option C, and this question is for 1 mark. I hope that you can understand the concept from each question. If you have any doubt, then you can tell me in the comment box. Now today we will stop here and we will continue in the next video. Till then, stay motivated and happy practicing.